Okay, guys, so the way to do an exponent greater than 2 is, I'm trying to do the arrow over here. If you look where the division bar is, there's this arrow pointing up, okay? So you have to type in the base first, which is 4. Then you're going to type this button here. That arrow pointing up gives you the exponent box. And then you put in the 3. And you hit enter. You're going to have to give me answers to values of exponents greater than 2 on our practice today. So you have to know how to do this on the calculator. I can't stress this enough. Okay? So on number 1, the answer is 64. On example 2, they give you a -3 squared. So the negative is next to the enter right there. Then the 3 to square it. You should already be familiar with that. That's over here above log. That always gives you an exponent of 2. You get a -9. But for number 3, so this is where we are. We got this one is 64. This answer is -9. To get this answer, because they're using parentheses, you have to use parentheses in the calculator. So on the calculator, the parentheses are above 8 and 9. Open parentheses is above 8. Then we're putting in a -3. Close the parentheses is above 9. And now we're going to square that base and hit enter. And you get a +9. So when you have parentheses or you have an integer, you need to put it in parentheses to get the correct answer. So this one was a +9. All right, so we're going to check your 0 exponent. Just watch what happens. Do 4 to the power of 0. If you forget, you should be able to type it in the calculator and see your answer. Same thing if I did 1983 to the power of 0. Do we see a pattern here? If I did a -2 to the power of 0. So what is so special about the power of 0? It always equals 1. So you have to memorize that fact. You need to kind of memorize this. Memorize this fact. So all of these answers here equal 1. Even if it's a variable to the 0 power equals 1, equals 1, equals 1. Now, the product rule we've done already. We started it when we did operations with binomials. But I'm going to show you how it works. I'm going to give you the expanded form so you can see the rule. If I do this base 2 to the 4th power, that means I have 4 factors of 2. So I'm going to write 2 times 2 4 times. Well, then I'm going to multiply that to 2 to the 3rd power. So that means I have 3 factors of 2. Well, when I look all together, I have a total of 7 2's here. So this final answer would have been 2 to the 7th power. Because you see 7 factors of 2. All right, so the key thing is product. Product means to multiply. So the product rule here is that when you multiply, basically you add the exponents. You keep the base. All right, so in number 1, Aiden, which number is the base?
4.
Okay, so I keep that 4, and then we add the exponent. So we would put above the 4, 5 plus 6, and then that actually would be 4 to the 11th power. Okay. And number 2, Camilla, what number is the base?
7.
Number 2, not number 3.
8.
Yeah, 8 is your base. you keep that base, so we keep the 8, and what do we do with the exponents? Alright, so if I did 0 plus 4, this would just be 8 to the 4th power. Ruby, what's the base? What's the base on number 3? Yep, 7's the base. Alright, what's our exponents? Nadia? What's the exponents?
For which one?
Number 3.
Number 3. The exponent is 1 and 6.
Yeah, 1 and 6. If you don't see an exponent, it's 1. So if I do 1 plus 6, this gets simplified as 7 to the 7th power. Alright, I want you to try 4, 5, and 6. We need to check your understanding of using the product rule. If you understand the rule, write your answer, the simplified answer. Alright, hopefully on 4, x to the 93rd. Okay. Keep your base, remember. On 5, the negative 5 is the base. So hopefully you wrote that to the 10th power. 2 plus 8 gives you 10. And then our last one, a to the 5th power. Are we okay on that rule? Because we have used this rule already. All right, now let's talk about quotient rule. Quotient is like division. A lot of times to show division, we use this fraction bar. So if we expand the numerator, 3 to the 7th means I have 7 factors of 3 on the top. So I'm going to do 3 times 3 times 3, 7 times. It's 4, 5, 6, 7. Then I'm going to do the same thing for the numerator. 3 to the 4th power means 3 times 3 times 3 times 3. So that's 4 times. I'm using 3. So I need you to write that. And this is how the quotient works. Normally when we have when we reduce a fraction, we cancel out like terms. So I can cancel out this 3 and 3. I can cancel that 3, this 3, and that 3. And do you see what we have remaining just at the top? We have 3 factors of 3 remaining, which means this would be a base of 3 with an exponent of 3. So 3 to the 3rd power would be our final answer. So what did I do with these exponents here, this 7 and this 4, to end up with 3 to the 3rd power? You subtract them, yeah. So when never doing division, that's what I wrote this little note. Division of exponents with same base, you subtract the exponents. Okay, you subtract the exponents. Let me see if I can get, hold on guys, I'm gonna check one more time. Nope, it's not there. All right. Okay, so on number 1 in this set, what is the same base? Yeah, so we're gonna write 12 first, and then we're subtracting the exponents. So that would be 10 minus 3. 10 minus 3 would give me a base of 12 to the 7th power, and that is our answer. So okay, so on number 2, what is the same base? Yeah, W. Okay, so this W is the same base, so we subtract the exponents. That would be 7 minus 6, right? Well, what's 7 minus 6? All right, 7 to the 1 power, right? Do I need to keep that exponent of 1? No. No, so we could just say our answer is just, oops, what happened? Hold up, sorry. Our answer is just W. Okay, you could just keep it as just W. And that would be the final answer. All right, I want you to try 3 and 4. Try 3 and 4. Let's check your understanding. See if you get the right answer. Let me see if it's here. What is this? All right. Display. Nope, it's still not there either. Okay. Our base is 4 that they have in common. So this hopefully 8 minus 5, you got 4 to the third. Here, our base is 7. That would be 7 to the 0 power. So your final answer actually is 1 here. Because remember, what is anything to the 0 power? 1. So that's why you put a 1 there. Or if you could have done this. Do you see how the base and the exponent are both the same? You could cancel them. If I cancel, you're left with 1. Okay, so either way will work. All right, now power rule. You need to remember you only use this rule when we see parentheses and an exponent outside that parentheses over here. This means we have 2 factors of the base 2 to the third. So we would say 2 to the third times 2 to the third power. Well, that's the same thing as saying in the expanded form 2 times 2 times 2 and 2 times 2 times 2, right? Which is just going to give you 2 to the 6th power. All right, so the key to the power rule is you have to see parentheses and we have to see an exponent outside the parentheses. To raise to a power, you multiply the exponents. So what I was trying to show you on the outside here, is if I have x, a, b, that's saying x is your base, and a times b. You're multiplying your exponents here. So to do this, you look at the base. 4 squared is the base. So you write 4 to the 2nd power, but then we multiply the exponent on the outside. So you just multiplying the exponents together. This gives you 4 to the 6th power. What happens when you do 6 to the 2nd power times 0? It would end up being just 6 to the 0. But what is anything to the 0 power?
1.
Yeah, that is our final answer. 1. All right, what about 8 to the 4th power raised to a power 8?
X to the 32nd power.
Yes, x to the 32nd power. To get that, you did 4 times 8. You add to multiply the exponents. All right, I need you to write these notes. This is a little different. This one right here, because we have parentheses here, we need to do the power rule first. So power rule first. That changes this to 2 to the 9th power. Okay? Then we're just going to multiply it to 2 to the 5th. Sorry. So it's power rule times product. Well, when they both have the same base and we're multiplying, what do we do to the exponents here?
Okay.
So this answer becomes what? 2 to the 14th. A bracket is the same as parentheses. So we take what's inside the parentheses, which is this negative 3 to the 2nd power. And we're going to multiply it to the exponent outside the parentheses. This leaves us with negative 3 parentheses to the 8th power. All right, and the last thing I want to talk about, the last rule, negative exponent rule, okay? You cannot leave a base with a negative exponent. You have to change it to a positive by doing the reciprocal. So what I'm trying to get you to see here is first put the base over 1, and then you're going to flip them to make it positive, okay? So we have a base of 3 to the negative 3. We're first going to put that over 1, like such. Then you're going to flip it to make it a positive exponent. So when I flip it, I would write 1 on the top and 3 to the third power on the bottom. 3 to the third power, this would reduce to 1 over 27. So simplify it when possible. So a to the negative 8th power. You got to remember that's like saying a, positive a to negative power over 1. To make that negative 8 a positive 8, flip it. So what are we going to write here? Yep, 1 over a to a positive 8. And that is our final answer. Now, for this one here, you might want to add just a little note. Because I see this dot right here, we're going to do product rule first. Product rule says when I have the same base, you add the exponent. So that means this becomes 2 to the negative 4 plus 6. That gives you 2 to the second power. And 2 to the second power equals 4. Okay, I'm just drawing what the whole number answers. All right, now this one, number 4, because we have these parentheses and that 4 is outside the parentheses like that, this is power rule. What do we do to the exponents when I see the exponent outside the parentheses? You multiply. So what I'm going to write here is that I have a negative 9 to the negative 2, times 4. I'm multiplying those exponents first. I'm sorry, the 9 was not negative. Let me take that off. All right, when I multiply that, that gives me 9 to the negative 8. Can I keep it like that? No. Okay, we gotta make it a positive. So let's put that over 1, and let's flip it. So when you flip it, 1 over 9 to the positive 8th power will be the correct standard form. All right, on number 5, because there's this division bar right here, we're doing the quotient rule, which means what do I have to do to these exponents? Subtract. So this is saying, 12 to the negative 2 minus 8. Subtract the exponents. That leaves you with 12 to the negative 10 power. Can I leave it like that? No. Put it over 1. Flip it. This actually becomes 1 over 12 to the 10th power. All right, now, do you see on the last one here, I don't know if you can see this, but this is a negative 5 down here. It's already over 1, it's already in a fraction form. We can't keep negatives, but to make it a positive, we flip it still, okay? So when I flip that, this becomes w to the 5th over 1, which is just w to the 5th power. Okay. All right, so your table of contents. We had, our first thing was the notes on operations with monomials. I'm going to give you your interest ticket from last week, and then the orange foldable goes in, and then some guided practice that we're going to do next. This is what I just passed out to you. This is going to go in after our orange foldable. You can use this foldable that we just did to help you. Just go to the tab based on the rule. All right. All right, on this first section, guys, you need to use a calculator. So everything here, okay, you need to use calculator. Okay, and I'm checking to see how well you can use it. So you're gonna give me a number answer. So you're gonna I'm gonna focus on the odds. So on number 1, you would type in 5 to the 3rd power and give me that number answer. Okay, so here we have it equals 125. This one has parentheses, so make sure you use your parentheses on your calculator. If you need help, you need to raise your hand. So parentheses -6, we are raising it to the 2nd power. Positive 36 is what we should have. No parentheses, so we just have to type in the integer -4. -4, and we're going to raise it to the 4th power, like such. We should get -256. So all I'm checking is that you are proficient in using the calculator to get your numerical answer. Using exponents greater than 2, okay? If it says cube, guys, that's the same thing. Sorry. It's to the 3rd power, okay? Cube means to the 3rd power. Square means to the 2nd power. Okay. So make sure you can get your numerical answers on the first 8. You have to be proficient in getting answers using exponents and calculator. I'm only gonna focus on the odds. I'll check proficiency with the evens. Okay. You would check your understanding with the odds as well. Okay, so when you get to rule number 1, rule number 1 is the product rule. And for this rule, it's trying to give you a reminder that you have to add your exponents. So they just want to see that you simplify correctly using the product rule. So here, this would be 5, the base of 5 to the 9th power. This would be 3 to the 5th power. And 9 to the 3rd power. That's all we're doing. It's simplifying using that rule. Okay. If your base is in parentheses, keep it in parentheses. I don't need the necessary numerical answer here. So what I want you to try to do, and they've given you hints for each rule, like what to focus on. Here we were adding the exponents. Sorry. Quotient rule, this is when you subtract. And you give your simplified answer. So if I have 5 to the 3rd power divided by 5 to the 1, this becomes 5 to the 2nd power. Okay. Here our base is 2, our exponents are 4 and 2. 4 minus 2 is 2, so 2 to the 2nd power. We're just simplifying using that rule. I know they're using division bar here, or division symbol. The same thing as saying 8 to the 5th over 8 to the 4th, which will give you 8 to the 1st power. Or you could just write 8. Okay? So you're gonna do all of them. You'll check your work with the odds because I'm gonna put the answers up here, and then I will check your accuracy with the evens. Now, when we're dealing with the power rule, okay, they give you an example. This is when you multiply the exponents. Now, to use a power rule, it has to be some type of grouping symbol and the exponent outside of it. So on 21, 5 to the third power raised to the power 6, that's going to be 5 to the 18th power. 6 times 3 is 18. This would be 2 to the 12th power. Okay. And then the last section is a mix review. Okay, so your mix, look at the problem, determine which rule, and then apply it and simplify. This is all product, so this would be 3, 5 plus 2 is 7, plus 1 more, that would be 3 to the 8th power. This is division, so this ends up being n to the 7th power. 9 minus 2 is 7. This one has parentheses, which is my power rule. So that's 2 to the 9th power. And then the last section, it says, make up 2 problems of your own examples for rule 1, which is product rule. So you're going to make up your own. The last part, answers can vary. Okay, because everyone's coming up with their own type of problem. All right, and so that's what you're going to work on. I will stamp check it as for completion in class before you leave, and then we'll check for right or wrong. Probably the beginning of class, because I want everyone to have a chance to finish it, and then come up with their own problems, and then we'll check.